Hello everyone. Welcome to the micro class of Construction Equipment Installation Project. This video is about the Power Distribution System overview. First, generation, transmission and distribution of electric energy. Second, power load classification. Third, power supply and distribution for civil buildings. As you know, electricity is produced in power plants, which are factories that convert various forms of energy into electricity. China's main power plants have thermal power plants, mainly burning coal. Hydroelectric power plants is the use of water potential energy to generate electricity. The most famous is Three Gorges Water Conservancy Hub Project. The Three Gorges Water Conservancy Hub Project is an important tool for the benefit of thousands of generations of the country, is the crystallization of the wisdom of the Chinese nation for 100 years in the construction process of the Three Gorges project, but also condensed the Three Gorges spirit of science and democracy, unity and cooperation, excellence, self-improvement. This is also the spirit that we should uphold and inherit in every construction project. Nuclear power plants are also the main power plants in China, which are famous like Qinshan Nuclear Power Plant, Daya Bay Nuclear Power Plant and so on. In our country, we have been exploring more and more clean energy, and we have built wind farms, solar farms, tidal power plants and so on. Previously, we said that thermal power plants are mainly burning coal. And now our country is still vigorously building a new thermal power plant, is waste incineration power plant.
Whether in urban or rural areas, the amount of waste generated by human activities is very large. Toxic and harmful substances generated in garbage. It will gradually penetrate into the underground and rivers. It will bring significant hidden harm to the environment that cannot be ignored. So harmless treatment of garbage has become an urgent task. Actually, garbage is not just waste. In a sense, the mountain of garbage is also an open pit mine. The key is how to develop and utilize these special resources. Burning garbage to generate electricity is the most economical way. The principle of incinerating garbage for power generation is usually simple, but the program is very strict. Firstly, it is garbage report. Does the quality of incoming garbage meet the requirements? It is the key to controlling garbage incineration. Therefore, it needs to go through a relatively strict sorting process. Eliminate toxic and harmful waste. Construction waste and industrial waste are not allowed to enter. Non-compliant garbage is discharged. Automatic weighing and measuring deduction. Put it into a huge enclosed garbage storage pool. The second step is to burn it in flames. A huge grab bucket. Retrieve garbage from the garbage storage pool. Put it into the nearby feeding hopper. After the garbage in the feeding hopper falls, get on the conveyor track and enter the incinerator. Under the action of driving equipment such as electric motors and blowers, ensure sufficient contact between garbage and air. Realize effective combustion. The large amount of heat generated by garbage combustion convert the water in the boiler into steam. Steam-driven turbine drives generator to generate electricity. The final generated electricity is integrated into the power grid. Garbage to energy is a measure to turn waste into treasure, killing two birds with one stone. With the improvement of garbage sorting technology, the combustion efficiency continues to improve. Garbage to energy generation will lend another helping hand to the country's environmental protection.
Through the video clip, we know that waste incineration and power generation is a good way to deal with the mountains of rubbish and turn them into treasure. And our scientists can also deal with the harmful gases generated after waste incineration, so as to meet the emission standards. But I think you have also noticed that the incinerated garbage is strictly selected, and not all garbage can be burned and disposed of. That is to say, the garbage should be sorted. And if we can strictly separate the garbage at the source, the job will be much easier. And some trash that can't be burned would be valuable somewhere else. So the government's garbage classification is an important part of our environmental protection practice. If you lift a finger, you can make our lives better. The electricity generated by our various types of power plants is transmitted and distributed to users through the power grid. Most of the power areas are far away from the power plant, and the electric energy needs to be transmitted far away. Considering the economy and loss, the use of higher voltage transmission is more economical. The power plant is limited by the level of insulation, and the voltage emitted cannot be too high. Between March the 15th to 15th, 7 kilovolts, and the current voltage levels usually used by generators are 6 kilovolts and 10 kilovolts. Therefore, in the transmission of electricity, in addition to the supply of users near the power plant, most of the electricity through the boost transformer to increase the voltage and then transmit it out. Generally, the farther the output distance, the greater the transmission power. The higher the transmission voltage is required. Depending on the distance, it is generally 35 kilovolts to 500 kilovolts. Of course, there are also higher UHV transmission. Of course, such a high voltage electrical equipment is not used, such as power transmission to the power area. Need to set buck substation. Reduce the voltage. Usually the transmission voltage is first reduced to 6 to 10 kV. There may be more than one step down in the middle, and it will pass through a multi-stage step-down substation. Then 6 to 10 kV of electricity is redistributed to load centers such as residential areas. There are terminal substations or distribution transformers that reduce the voltage to 380-220 volts. Supply power to low-voltage electrical equipment. This is the generation, transmission and distribution of electrical energy. Electricity generation, power networks and users make up our power system. For our electricity users, the urgency of electricity demand for different units of electricity is not the same. Therefore, according to the importance of the building and the loss or impact caused by the interruption of power supply. In politics and economy, the power load of civil buildings is divided into first-level load, second-level load, and third-level load. First-class load refers to the load whose interruption of power supply will cause significant political and economic losses or casualties. For example, important railway hubs, communication hubs, important international venues, important hotels, hospital operating rooms, important biological laboratories, etc. For the power supply of the primary load, in addition to the use of two independent grid power supplies, the especially important load in the primary load should also be set up backup power supplies, generally diesel generators or DC batteries. Interruption of power supply will affect the normal operation of real-time processing computers and computer networks, or interruption of power supply will cause explosion, fire, serious poisoning, and in especially important places, the first-level load that is not allowed to interrupt power supply is especially important load. Secondary load refers to the load that the interruption of power supply will cause great political and economic losses or cause disorder in public places. For example, local and municipal government office buildings, 3-star hotels, Grade A cinemas, prefecture-level main libraries, museums, cultural relics repositories, etc. In addition to using two independent lines for the power supply of the secondary load, standby power supply should be set up according to the actual situation. The power load that does not belong to the first load and the second load is the third load. The third-level load has no special requirement for the power supply of buildings. Then let's take a look at how to power supply and distribution of civil buildings. Usually the power load of civil buildings below 100 kilowatts The General Low Voltage Distribution Room 380V/220 volts direct power supply. Civil buildings with an electricity load of more than 100 kilowatts are divided into small, medium, and large civil buildings with different basic forms of power supply. The power supply of small civil buildings generally only requires a simple 6 to 10 kV step-down substation. For the power supply of medium-sized civil buildings, the power input line is generally 6 to 10 kV, and the high-voltage distribution line is connected to the substation of each building by the high-voltage distribution office, and the reduction is 380/220 volt. The power supply of large civil buildings. Due to the large power load, the power supply line is generally 35 kilovolts, which needs to be reduced twice. The first time 35 kilovolts is reduced to 10 kilovolts, and then the 10 kilovolts high voltage distribution wire is connected to the substation of the building, which is reduced to 380/220 volt. Distribution system consists of distribution devices and distribution lines. Distribution forms are mainly trunk type, radial type, chain type, hybrid type. Distribution system should be selected according to the specific situation. The radial type is that each rear-end distribution box is connected to the front-end distribution box by a separate line. Advantages: high reliability of power supply, easy to measure and economic accounting, centralized equipment, easy maintenance. Disadvantages: non-ferrous metal consumption is more. The use of switching equipment is also more. And the investment cost is high. It is suitable for large capacity of electrical equipment, concentrated load or important electrical equipment, or workshops and buildings with special requirements. Trunk type is that each distribution line led from the power supply point can be connected to several electrical equipment or distribution boxes. Advantages: flexible distribution form. Non-ferrous metal consumption is less. The total investment is less. Disadvantages: when the main line fails, the impact range is large, and the reliability is low. It is suitable for use when there is less power equipment, and the power supply line is long, and the temporary power supply on the construction site is suitable. A chain system is similar to a trunk system. The characteristics are also similar to the trunk type. Advantages: there is no branch point on the line, which can reduce the power failure range caused by a certain section of the line fault, and the power supply reliability is improved compared with the trunk type, which is suitable for pipe laying and saves non-ferrous metals. Disadvantages: the overall power supply reliability is poor. It is suitable for small capacity equipment with dark laying lines and low power supply reliability requirements. Generally, the connected equipment should not exceed 3 to 4 sets, and the total capacity should not exceed 10 kilowatts. The hybrid system is a combination of radial type and trunk type, and the distribution form in practical engineering is mainly hybrid type. The hybrid system has the common characteristics of radial system and trunk system. It is suitable for the occasions where there are more power supply equipment or distribution box. The capacity is relatively small, and the distribution of electrical equipment is relatively uniform. This is the basic form of wiring. That is all to this video. Welcome to continue to watch other videos of the construction equipment installation project course.